This video is on the objective solve factorable trigonometric equations in quadratic form. All right, let's just take a look at the question. So again, if you want to see what they're saying about this, click on more instruction, look at their videos, their notes, their examples, and hopefully those help you out. So here we're asked to, it says, given that, x is between negative pi radians and positive pi radians, but, not including positive pi, find all the solutions to the equation 2 times the tangent of x squared, right, tangent squared, minus 2 equals 0, and then, separate your answers if there's more than one with commas. All right. So when they talk about an equation being in quadratic form, hopefully you remember back to either pre-calc 1 or some previous algebra class you've taken. That's just where you have some number times of an unknown squared plus some other number b times an unknown to the first plus a constant equal to 0. You might recall this from, again, a pre-calc 1 or a prior algebra class. I'm hoping you've seen this. Now you could solve an equation like this with the quadratic formula, but in this particular objective, we'll be able to solve all our equations like this by factoring. So you're going to get everything to one side, 0 on the other, and then you're going to factor this expression on the left side or the right, whatever side you put it on, and set each factor equal to 0. Because remember that we're also going to be employing the zero, what's called the zero product property. Right, and the zero product property states that if, say a times b is equal to 0, right, if you have a product equal to 0, then either a is equal to 0 or b is equal to 0, or both, but I'll just leave it with this. So hopefully this rings a bell, right, again from pre-calc, from some previous algebra class, how to solve a quadratic equation by factoring. Alright, so I'll write out the equation we have here. We have 2 times the tangent of x, but this is the tangent squared. So this is like my x squared. This is some unknown, right, the tangent of x, but, squared, minus 2 equals 0. Right. Now this is, again, like a quadratic, because you have an unknown to the second power, and that's the highest power you're seeing on that unknown, that tangent of x. Now something they suggest in the more instruction in Newton Alta here is to make a little substitution. The unknown quantity here is that tangent of x, right? And what they're saying to do is, hey, why don't you substitute some letter for this, just so you don't have to keep writing it over and over again. So say instead of the tangent of x, for now, we'll substitute back at the end when we need to find solutions. Let's call it, whatever you want. I'm going to call it m, just because. Right? You can call it m, n, x, y, whatever you want. And that'll give me this looking equation, right? So everywhere I see a tangent of x, I'm going to replace it with the letter m. So now this equation looks like this. I have 2 times m squared, right? Tangent of x squared, m squared, minus 2 equals 0. And this is in this quadratic form, right? Here you have your quadratic on one side, 0 on the other. And what I'm going to do now is factor this quadratic completely. Now the greatest common factor is the first thing you should pull out. Notice that both these terms have 2 in common. So I can factor out a 2 right now, and if I do that, what's left over would be m squared minus 1. And this is still a product equal to 0 here, and the m squared minus 1 is one of those difference of 2 squares, right? This is m squared minus 1 squared. And the difference of 2 squares factors to the product of binomial conjugates, so you don't have to worry about all the fancy words. It's just m minus 1 multiplied by its conjugate, m plus 1. Okay, and then I should say factor completely. Alright, that's what I've done, is factored it completely, because I can't factor any of these expressions anymore. And then we apply the zero product property. Right, I'll just call it the ZPP, right, zero product property. I have a product equal to 0. So by the zero product property, either 2 is equal to 0, but you're not getting anything out of that, right? There's no variables in that. That doesn't make any sense. So I'm getting no solutions out of that. Or m minus 1, right? The second factor could be 0. Or m plus 1 could be 0, right? And then we solve for m here, so either m equals 1 or m equals negative 1. Now, our original equation was in terms of x, right? We have the tangent of x. I want to solve for x. I want to find numbers I can replace x with, not this m that we substituted for. So now I'm going to substitute back, and we'll solve for, find values of x that make the equation true. So now we substitute back, and we're now looking at, remember, m replaced the tangent of x. So now you have the tangent of x is either equal to 1 or the tangent of x is equal to negative 1. And we need to solve both of these. Right? You need to solve both of these for x. So I'll start with the tangent of x equals 1. Right, now we're down to, instead of a quadratic equation, now we're down to looking at 2 linear equations, right? You have tangent to the first, and you saw the solutions of, how to solve linear equations in a previous assignment. So the tangent of x equals 1. So remember, I isolate the trig function, which is already done. Remember, then I think about the unit circle, just going once around the unit circle. And, what values of x, what angles have a tangent of 1? Well, x could be, pi over 4? Right, that had a tangent of 1. Right, pi over 4, 45 degrees, And then I could add 360 or 2 pi, subtract 2 pi. I could add any multiple of 2 pi to this, and it would still give me an angle that had a tangent of 1. It would still give me a solution to this. So I could add 2 pi k, where k is, some integer. But also, right, that's not the only angle that had a tangent of 1. So did 5 pi over 4 in quadrant 3. X could also be replaced by 5 pi over 4. And then, when I'm at 5 pi over 4, I add 2 pi, subtract 2 pi, right? We could add any multiple of 2 pi and get another solution. All right, so remember, this is the general solution. This is a description of all possible solutions to this equation. And now what I'm going to do is list some. All right. So here's me listing some solutions to this first equation. Again, I'm just going to be replacing k with certain values. So if k were 0, you'd get, pi over 4 is a solution, and so is 5 pi over 4. And then going in this direction, I would just be, every time I increase k by 1, I would just be adding 2 pi, right? Which is the same as 8 pi over 4, right, if I'm getting a common denominator. And if I go in this direction, let's say I'm decreasing the value of k by 1, and every time I decrease k by 1, I'm just subtracting 2 pi, or subtracting 8 pi over 4. Alright, so on the top one here, this solution, pi over 4, if I just keep adding 2 pi, I get 9 pi over 4 is another solution. 17 pi over 4 would be another solution, and so on. Then I'll go the other way too, subtract 8 pi over 4, right? Subtract 2 pi. Negative 7 pi over 4 would be a solution. Negative 15 pi over 4 would be another solution, and so on. And I'll do the same to this solution of 5 pi over 4. Just keep adding 2 pi. That'd be 13 pi over 4, 21 pi over 4, and so on, right? I'm just listing all sorts of solutions to this first equation here. And subtracting 2 pi, negative 3 pi over 4, and doing it again, negative 11 pi over 4, and so on, right? So I have just listed for you here 10 solutions to this first equation, right? When is the tangent of x equal to 1? And these would also be solutions to the original quadratic equation if they're satisfying this one. But remember, they want, not all these solutions. They want the values of x that satisfy this inequality. The values of x between negative 1 pi and positive 1 pi. So looking at my list here, pi over 4 is in this range. 9 pi over 4 is bigger than pi. Right? 17, those are all too big. Negative 7 pi over 4 is smaller than negative pi, because negative pi would be negative 4 pi over 4, so these are too small. So from this top row, only pi over 4 works in this range. And from this second row, 5 pi over 4 is too big. Pi is 4 pi over 4, so that's too big, but this one, negative 3 pi over 4 is in here. Right? This is negative 4 pi over 4 to positive 4 pi over 4. So, and then the other one's too small, these are too big. So the only two solutions I'm getting from this first equation are pi over 4 and negative 3 pi over 4, right? That are in this range that they gave us from negative pi to pi. Alright, so I'm going to do the same thing for the other equation, right? That was the tangent of x equals 1. What about when the tangent of x equals negative 1? So I'm doing the same thing, looking at the other equation. When is the tangent of x equal to negative 1? So again, the trig function is isolated. Right? The trig function is alone. And then I just think once around the unit circle, right, going counterclockwise. Just think once around, what angles have a tangent of negative 1? Well, those would be in quadrant 2 and quadrant 4. 135 degrees or 3 pi over 4 radians, right? That had a tangent of negative 1. And then if you were to take 3 pi over 4 and add any multiple of 2 pi, so again, add 2 pi k where, k is an integer, you'd get another angle that had a tangent of negative 1 as well. But that's not all, right? That's in quadrant 2. In the quadrant 4 angle would be 7 pi over 4 radians, right? This angle had a tangent of negative 1 as well, and then again, plus any multiple of 2 pi. You add 2 pi, subtract 2 pi, you'd be back at the same spot. So plus 2 pi k. Right, so there's the general solution, right? Here's a description of all the infinitely many solutions to that equation. And also the original quadratic equation, right? Because if you satisfy this one, you're going to satisfy the original. And then I'll list some here. Here's a list of solutions. More solutions to this equation. Now, if k were 0, 3 pi over 4 is a solution, and 7 pi over 4 is a solution. And then again, all that's going to happen here is, as I go to the right, I'm going to be increasing k by 1. Just going to keep adding 2 pi, which is again 8 pi over 4 if I get a common denominator. And as I go left, I'll subtract 2 pi. Right? So on the top row, 3 pi over 4, just add 2 pi, that'd be 11 pi over 4, would be another solution, and so on. Right? I just know that these are too big, right? Because remember, we're only going to find the solutions in the range from negative pi to positive pi. Then subtracting 2 pi would be negative 5 pi over 4, right? And that's too small, so I'm not going to write any more. And then doing the same with this row, just adding 2 pi, this is already too big, so I don't know why I'm going this way. But subtracting 2 pi gives me negative pi over 4, and doing it again gives me negative 9 pi over 4. And that's too small. That's too small. Right. Okay. And we're looking for, again, values of x that are in this range. Right, we want values of x in this range from negative pi to pi. Well, 3 pi over 4 is in this range. These are too big. These are too small. Then in this row, negative pi over 4 is in this range. These are too big. These are too small. So I'm only getting those two out of here. So all told, after all this, the solutions that we're going to write down, the solutions that we want, I have, again, here were the two from up here. So if I'm going to put them in order from least to greatest. So we had negative 3 pi over 4, then negative 1 pi over 4, then positive 1 pi over 4, and positive 3 pi over 4. So here's what I'm going to type in. Right, those are the 4 solutions to this equation that are in the range that they asked for. Right. And again, you can always check these solutions, right? Go back to the original equation. Right, the original equation was this thing. 2 times the tangent of x squared minus 2 equals 0. And plug any of these in for tangent of x. The tangent of pi over 4 is 1 over the square root of 2. When you square it, that's a half of 2. I'm sorry, the tangent of pi over 4 is 1. And then when you square it, that's 1. 2 times 1 is 2, minus 2 is 0. So pi over 4 works, and the same would work for any of these. All right, so back on the website, I'm going to enter all 4 of these values. Now you don't have to put x equals, right? You just put the numbers that are solutions. So one of these was, again, negative 3 pi over 4. Then separate the answers by commas. Comma, negative 1 pi over 4. Comma, positive 1 pi over 4. Comma, and then positive 3 pi over 4. And that's it, all 4 of those. It's like, hey, you nailed it, hooray. And again, read through there. Now you see they did here, and I'm going to be doing this in future video, in the next video in this objective. Instead of doing that substitution, I'm just going to factor it with the trig function still in there. See how they, instead of replacing the tangent of x with some other letter like m like I did, they left it as tangent of x because it still factors the same way, and ended up finding out. And they're using n instead of k. I know I've been using k for my integers. They're using n. So, whatever. Alright, great. So hopefully watching me do this, or looking at their more instruction, reading their answer explanations, hopefully all this stuff helps you when you're working on this kind of a material on your own. And thanks for watching.